Thanks for joining us today. Good morning, good afternoon for some. I know Hall and I are excited to go through some diagnostics, some troubleshooting on the direct liftgate charging system. So that's what we're going to do today. Some of the things we're going to cover, some of the different changes over the years, which is very few. We're going to go over a basic function of the direct liftgate charging system. Diagnosing the liftgate charging system, and going to look at the tractor side and kind of show you some diagnostics on the source side or the tractor side. So to get started, some of the changes over the years. First one being, a noticeable one would be the different style of fuse that we're using now. The one on the left there is a maxi fuse. It's a 30 amp maxi fuse. This is located on the inside of the direct controller and protecting the different circuits. The one on the right is a MIDI, M-I-D-I fuse. Both are really great fuses. The maxi fuse has a really good surface area. Handling that high current, you need that surface area. And so does the MIDI fuse. The reason why we chose the MIDI, the M-I-D-I fuse, is it's more of a solid connection. It's a bolt-on style, and you're going to eliminate, pushing that, maxi fuse in and out. You're going to cause pitting. And what you get with that is some high resistance built up over time. We haven't really seen that with a maxi, but we just made the decision to move to a MIDI fuse just for a better connection. And another noticeable change would be our decal on the front. We have a white decal and a blue decal. The blue decal is our latest and greatest. Really, the biggest thing, cosmetic, it looks a little bit better, but the biggest reason we did that is to denote the difference in fuses that we're using now. We went to that MIDI style fuse, so that really points out, if you have a blue label, you have that new style fuse. So I'm going to turn it over to Hall to kind of go over some of the LED scenarios.
Hey, everybody. Like Jimmy said, welcome. Glad you're here with us. I'm just going to walk through some basic functionality of the direct system before we get into the diagnostic side of things so that we're all on the same page. So with the direct, we have our two LEDs on the front of the controller. One of these is an indicator for the source side of the system, generally the tractor, and one of them is an indicator for the liftgate battery side. So as you can see in this picture, both lights are solid green. When they're solid green, that means the system is on and charging. In order to do this, it needs to see at least 13.8 volts to start that sequence up. We did that to protect the truck batteries so that they're not discharging to charge the liftgate batteries when the truck is off, which could have a no start event. So when these two are solid green, that means it's on and working and you are good to go. When they are blinking green, and this is for both sides, that means that the system is not currently charging, but that the voltage is between 12.4 volts and 13.79 volts. So for example, if the liftgate batteries are in a good state of charge, but it's unplugged from the tractor, then you'll see that blinking green light just telling you that it's a good state of charge, but not currently charging. So specifically on that lift battery side, like we said, if it's blinking green, it means it's good voltage, above 12.4 volts. It's just not currently charging because the truck's not on. If it's blinking orange, that means that it's low voltage. This could just mean that it has been sitting for a long time. It could mean a number of things. That doesn't necessarily mean that there's something wrong with the system. It just means that your liftgate batteries are below 12.4 volts. If you see no lights on that liftgate battery side, and really this would be if you see no lights on the lift battery, you'll also see no lights on the source side. What that means is that you have either a blown 2 amp fuse at the battery box. So in the battery box, we have our plate assembly, and there's a little 2 amp fuse on that. That is put in place to protect this controller. So if there's a short in the battery box before we had this 2 amp fuse, it would it could damage the controller on the front. So we simply put the 2 amp fuse in place to protect that. If it blows, no power will get to the controller, which means there will be no signal going to the front and no lights on the front. So first thing to check if you see no lights on the on there is 2 amp fuse, and we'll get more into that later. Second option, or the second thing, could be voltage at the liftgate batteries under 7 volts. Similar with the source, really the exact same. If it's blinking orange, that just means your voltage is below 12.4 volts on the source. So once you plug in the 7-way or dual pole or whatever that might be, if it's reading low voltage there, that doesn't necessarily mean that the system won't start when the truck starts. It's just telling you low voltage. If it's blinking green, that means your voltage is above 12.4 on the source. You should be good to go once it starts. Again, it's not guaranteeing that, just telling you what that voltage is at. And lastly, with the no light, again, since the controller gets its power from the liftgate batteries, this will again be caused by the 2 amp fuse at the liftgate batteries or voltage below. I think the last slide said 7 volts, but it's be below 6 volts. And that's kind of, we'll get more into that later, but that's kind of a bit of a hairy line. Just
yeah, it's a pretty fine line. It's between 6 and 7 volts.
Yeah.
Most electronics, any electronics need at least that, that 6 to 7 volt range to even power on.
Yeah, exactly. So, so if the 2 amp fuse is intact, then that'll be testing, and that's what we'll get into now. So if you do not have LEDs on the direct controller, there are 3 steps to go through to diagnose that. The first step, as we just talked about, is checking the 2 amp fuse at the plate assembly in the battery box. So as you can see on this picture on the right side of the slide, that is the plate assembly. It's kind of a close-up view. And at the bottom of that picture is the fuse holder. That's going to be that 2 amp fuse, which is pictured there on the slide as well. If this is blown, it will not allow power, the power signal, to get to the controller. All that signal does is indicates to the controller, hey, this is the amount of voltage that I'm getting back at the battery box, and tells those lights to come on. If that signal is not getting to the front, then those lights will not come on. So first thing you want to check is see if that fuse is blown or not. If it is, replace it, and make sure we're replacing it with the 2 amp fuse. That is a small wire and cannot handle high levels of power going through, high amperage going through. So we do have that small fuse in there for that reason. If it is not blown, then the next thing you're going to want to check is the liftgate voltage. So in order to do this, you could check it directly at the liftgate batteries, but just going through it, since it kind of goes through our wire and again sends that signal up to the front, really skip a couple steps, and the best place to check it is actually on that orange wire at the plate assembly. So you put the positive lead on the orange wire, the negative lead on the ground, and you want to see what the voltage is right there. And that voltage should be above 6 volts. And again, just to be safe, above 7 volts, just because that line can be a little gray sometimes. So if you test it there and you see good voltage, then the third step is to move up to the direct controller at the front of the trailer. And you're going to do essentially the exact same thing. You're going to check that orange wire there, and all you're looking for is to see if the voltage you saw at the liftgate battery box is the same as the voltage at the controller. So if you test it there and it's above 7 volts, if you have good voltage at the front, but you still have no LEDs, you might have a bad controller. If there is no voltage at the front at this controller, but there was at the liftgate batteries, then there's going to be something along the harness that has happened. So it might be a cut, it might be corrosion. They're really that's about it. But something along that harness. So that's where you're going to want to check, and that's where you should find the issue.
And just to kind of add into that into the group, if you're if you're actually looking at the user guide and walking through step by step, it's going to go into a little bit more detail. Checking right at the battery and kind of working your way up the circuit. We kind of, putting this together for everyone. We realize time is very important. So, use this presentation to get to that root cause a little bit faster, and that's kind of why we put this together this way. So, really, we always tell everybody the first thing you ought to check when you're diagnosing. First, you got to have a voltmeter, know how to use it, but you got to know what your battery voltage is, your liftgate battery voltage. So, just wanted to add that in there.
Yeah, perfect. Thanks, Jimmy. So we've got a little question here. Just make sure everybody's on the same page with this. So the question is, what LED scenario indicates that the liftgate batteries are charging? Blinking green on both sides, the source and liftgate battery. Solid green on both sides, or blinking orange on both sides, or all of the above. So take a few seconds, if you will, put in an answer there, just so we make sure we're all on the same page going forward. All right, so let's see what our results are. Solid green on both source and lift battery LED is 81.3%. That is the correct answer. So nicely done, everybody. Just to clarify, the blinking green on both source and lift battery, it means that the voltage is at a good state of charge on both the liftgate battery and the source side, but the system is not on and charging. When it is on and charging, those lights will go solid green to indicate that change. Jimmy will take over to discuss what happens when those liftgate batteries are not charging.
All right, thank you, Hall. Yeah, so we talked about you got to make sure the controller is working first, which Hall discussed that. Now we're going to go through kind of step by step what you can do to diagnose if the liftgate batteries are not being charged. First thing you want to do, you want to make sure you have, just like that last question, you want to make sure you have the solid green on your source, solid green on your lift battery. Again, that's saying that you're pulling power from the tractor. We've achieved that 13.8 volts, and we've started the sequence. If you cannot get past this part, then you really need to look at, if you can't achieve that 13.8, you need to look at your, the tracker side. Maybe the alternator is not outputting what it should be. Maybe that voltage cannot get to where it needs to, which is the direct controller. So you got to get to this point first. Then we're going to kind of use, process of elimination. Again, you must know how to use a voltmeter. You can refer back to some of our, later webinars that just, that go over the fundamentals of using a multimeter. But all service written material is written with the assumption that you know how to use that meter. So in this example, use your voltmeter, put it on DC volts. Then you want to measure, what your input voltage is. So if you put your positive lead on your black wire, which is your input, and then your negative lead on your ground, you want to make sure you're reading tractor voltage. If you're not, then you could possibly have, blown fuse in that circuit, whether it be that green maxi fuse or this 30 amp MIDI fuse, which is the new style. So you want to make sure that's not blown. Then you want to move over to the yellow wire, which is the ignition. I like to think of the yellow wire or the ignition wire as the on-off switch for the charger or the DC-DC converter that's mounted at the liftgate battery box. It's either on or off. So once we've started that sequence, you have solid green on the source, solid green on your lift battery. This yellow wire should read 12 to 13 volts. Sometimes, we've taken calls where they get 1 volt or just a little under a volt. That's not on. That's not what it should be. So you got to see 12 to 13 volts on this yellow wire. If you don't, at this point, I would inspect the connection there, make sure it's tight. Make sure there's no loose connection, make sure there's no corrosion. This could have had someone else worked on it. If it was a road call or something, just make sure it's a really good connection and in the right spot. So what we're going to do now is we're going to go back to, we've done everything up front, we're going to go back to the liftgate battery box and basically do the same thing. With our voltmeter set on volts, we're going to look at that input voltage. If you pull that 4-pin plug, as you see in the picture there, that 4-pin plug plugs right into the DC-DC converter or the charger. You want to measure the voltage on pin number 1, which is your black wire. That's your input positive. Then you want to put your negative lead on the pin number 3, which is your white ground wire. And if you look on the back of that 4-pin plug, it's numbered. But I put the wire colors in here to make it easier. But just like at the front, you want to read that input voltage. You want to read tractor voltage. If not, then there's got to be an open circuit from this 4-pin harness to the direct controller up front. So repair that circuit and move forward. The next step would be, just like we did up front, we're going to measure to make sure we have ignition power at the back, which is your yellow wire, pin number 4. With your voltmeter, put your volt lead on pin number 4, which is that bottom left, if you're looking at it at the picture, and then the ground wire, which is the white wire, right above the pin number 4, which is ground. You want to make sure you're reading that 12 to 13 volts, just like you would up at the front. Again, that's like a light switch. That's your on-off switch. If it's off, that charger is not going to come on. If you're reading 12 to 13 volts on that pin and you plug it in, that charger should come on. Very rarely do you have these DC-DC converters are pretty rock solid. We just do not see them fail. So that's why we're walking through these steps to eliminate what the problem could be. Typically, everybody wants to kind of jump to the charger when, if you walk through these steps, you're going to find the issue. So now we're going to measure. We're going to measure our output. Make sure we know that we have. If we figured out that we have ignition, we have input voltage. Now we want to see if we have a good connection to our liftgate batteries. So with that plug, that 4-pin plug unplugged, we can do that right here at the plug. We can put our negative lead on our negative voltmeter lead on the white wire, which is the ground, our positive lead on the red wire, which is pin number 2. That's our output to our liftgate batteries. So obviously, with it plug, connected here, you want to see liftgate battery voltage. That's how you know you're going to have a good connection to your liftgate batteries. And when this is plugged in, and the converter, DC-DC converter or charger working like it should, it has an output path to those liftgate batteries. If you don't get any voltage here, then you want to follow it back to the liftgate batteries. Follow this circuit to the liftgate batteries. The next connection in line, there's a 30 amp circuit breaker. Make sure that 30 amp circuit breaker is not tripped, and you have a good path to those liftgate batteries. So we have a question here. Where does the direct controller get power from to operate? And I'm not asking, I'm asking where does it get that power just to turn on and get lights on the front? So I'll give everybody a few seconds to answer that. right, let's review the results. So 52% say it's from the tractor, 42% say it's from the liftgate batteries. Then we have 5.3% say all of the above. The real answer is from the liftgate batteries. Again, we have to even power that module, you know, Hall discussed earlier, you have to have that 6 to 7 volts to even power it on. And that voltage comes from the liftgate batteries. When the trailer is just sitting on the yard, you should always have a lift battery light. So in order to do that, we have to get that power from the liftgate batteries. Okay, so I'm going to turn it over to Hall to go over some of the other LED scenarios that you could experience.
All right, thanks, Jimmy. So so we've talked about the standard LED situations you'll see: the blinking green, blinking orange, solid green. So let's look at a couple others that you might run into. So one that you may see. So we talked about when the voltage is low, you'll see kind of a slow flashing orange to indicate that. Another thing you could see is a very rapid flashing orange on the liftgate battery side or the source side. And it's a very quick flash, so it should be pretty easy to differentiate between that and the slow flashing orange. But what that means is typically 99.9% of the time, that means there's a blown fuse behind that light. So if it's a lift battery light that's flashing quickly, that will be the liftgate fuse, the fuse on that circuit that has blown. If it's on the source side, then it'll be that source fuse. And I personally have not seen this in the field. It's very rare, but if for some reason you're getting those rapid flashing lights and the fuses are both good, you want to check the truck side, and it could be that there's an open circuit on the truck side, whether it's most of the wires are broken and there's just a little scrap there still connected or whatever it might be. But if for some reason both of those fuses are still good, you want to check the tractor side. But again, 99.9% of the time it's going to be a blown fuse. That's what that light is there to indicate. So when you do see this, the way you can test those fuses, there's a couple ways. One is to get your multimeter and to set it to ohms. And you want to measure the resistance along these fuses. So you want to place the positive lead on one side, the negative lead on the other. It doesn't matter which side you place which lead. Just make sure they're across that fuse, and you want to look for a reading of 1 ohm or less, and that will be your good reading. That'll tell you that the fuse is good. If it reads OL, that means it is out of limits or it is bad. Another thing you could do is a continuity test. If your multimeter has that, you know how to set it. And essentially what that does is it, again, place one lead, the positive lead on one side, the negative lead on the other. And if there's continuity within that circuit, meaning the fuse is still good, your multimeter will beep at you. Generally, it gives a nice loud beep that tells you that the fuse is good. So if you have that, you can use it. This is a good guaranteed way that all multimeters should have to be able to read that fuse. Check if it's still good or not.
Yeah, and just to add to that, Hall, we put this in here because that's the first thing most of us do whenever we think it's a blown fuse. We take it out and hold it up to the sunlight to see if the element's broke. I've seen it, witnessed it firsthand. It may not look broken, but there may be a break in that element that you just cannot see. So, to keep from, going down the wrong path on diagnosing, it's best just to use the voltmeter and check it the proper way for to see if it's blown or not.
Yep. Yeah, exactly. Thanks, Jim. So one question we get asked is, why do we fuse the ground circuit? The reason we've done this is, years ago when we first started this, we did not. And what could potentially happen is if the liftgate pump motor is not grounded properly, it pulls out 150 amps or more, and electricity is lazy. It looks for the easiest path possible. And so it'll go search around for a ground, and it finds our 8-gauge ground wire, which it then tries to use to as its ground. But our 8-gauge wire is not designed to handle that kind of current. And what happens is this, just like in this picture you see on the slide, you can actually get melting of that wire because it just gets so hot from all that power going through it. So we provide a fuse on the ground side to keep that harness protected and to keep our system protected. So that is why that is there, in case you're curious. And we want to make sure that it stays there and is good. So I had somebody send this question in: what is going on when you see these blue LEDs? So if you are looking at your direct controller and you see blue LEDs on the front, don't worry about it. That is a normal occurrence. That just means that it is starting up. So in certain situations, it might need to reset itself. And when that happens, you'll see these blue LEDs come on, and they should come on for a minute or two while it goes through its checks, make sure that everything's intact and working, that it has proper voltage, all of that is not going to damage itself when it turns on, and then it will come on. So that is a normal thing. If for some reason your blue LEDs stay lit and they do not go off after a couple minutes, this could mean, we talked about earlier, that gray line between the 6 and 7 volts on the batteries. This could mean that your batteries are right around that range, so they have enough to sort of signal to our system, hey, I can turn on, and then it starts to turn on, tries to, and it just doesn't quite have enough power to finish that process. So if, after a couple minutes, your blue LEDs do not go off, if they stay lit, you just want to charge and test your Liftgate batteries to make sure they are up to a good state of charge, and then try it again, and that should solve the problem. So hope that answered your question before. So we have one more poll question. With the trailer uncoupled from the tractor, what LED should be lit on the direct controller? So if the trailer and tractor are not connected, what LED should be lit? Liftgate battery LED, source, neither, or both? Give it a few seconds to answer that. All right, let's see what we got. Liftgate battery LED, 81%, and that is the correct answer. If the tractor is not connected to the trailer, you will have no light flashing on the source side of the controller. What that light on the source side does is, once your source is plugged in, it tells you whether your source is good or not. If the batteries on that source are at a good state of charge. So if you don't have a source plugged in, then you'll have no light on that source LED. All right.
Okay. So we've talked about, what the LEDs do, what they should do, diagnosing, no LED and diagnosing, not charging the liftgate batteries. We got to get this power from somewhere. And we get that power via the tractor. We can get that either, by the dual pole, the single pole, with a straight truck application, would be directly to the truck batteries. We can also get that through the 7-way circuit, which we'll talk about next. But here, showing some examples of dual pole. Again, you must achieve that 13.8 volts to even start the sequence. And we get that from the tractor. Some of the things to look at, dual pole is, the integrity of a dual pole circuit versus, single pole or even 7-way is much, much greater. You got larger cables that you're working with. Typically, they're a 2-gauge cable. Just a lot less connection points. But if you look at the examples here, that dual pole receptacle, in what I've experienced, is pretty vulnerable where it's mounted. Typically, you'll see it corrode right at the connection point where the cable connects to the receptacle. As you can see in the picture there, I just barely touched the cable and it came off. So you really want to inspect that connection point. You really don't want to see any kind of tape, wrapped around the connection. You want that dual wall adhesive line heat shrink to really seal that connection. Again, our charger, our DC-DC converter, pulls. It's a 20 amp converter. It'll pull 20 to 25 amps. That circuit has got to be able to handle that load. So looking at the 7-way circuit, same thing. We still got to achieve that 13.8. So again, that circuit has to support that 20 to 25 amp load. What do you have with a 7-way circuit? You have much smaller wire. Typically, it's 8 gauge, 10 gauge wire. You have a lot more connection points between the truck. It's got to go through a control panel, through all the connections at the battery, and then up to the receptacle, through the 7-way cord, and to our controller. So there's a lot of connection points that can choke off that voltage and that current flow. And by the time it gets to our controller, it may be too low. So the integrity of that 7-way circuit, if you take care of it, it's good, but you are dealing with a lot more connection points there. And kind of diving in, one of our most common faults, I've seen it on the dual pole, but typically it only happens on the 7-way circuit. And what you'll get, we call it excessive voltage drop, and what you'll get is when you achieve that 13.8, we've started the sequence, so I should have solid green on my source, solid green on my lift battery. So that happens, my converter charger turns on, now I'm pulling a load through that tractor, all those connection points, and by the time it gets to our controller, it may have dropped below our threshold, which is 9.5 volts. We do that. We have to shut that off because we have to save power for the ABS. That's one of the key features of our product. So if you get this, what it does, if it drops below that threshold, that 9.5, it'll shut, our controller will turn off the ignition. And basically what it'll do, you'll get the little railroad symbol. It'll alternate back and forth on the source LED and your lift battery LED, and it'll be orange. So once we've shut off, what happens to our voltage? It starts to climb back up and it reaches that 13.8, and it's just a vicious cycle. So it keeps repeating itself. So if you have that scenario, you don't want to look at, really look at the trailer side. It's more on the tractor side. You want to make sure, you got a good solid connection from your tractor through all the connections and up to our direct controller. We have to see that 13.8 at the controller, and we cannot drop below that 9.5 volts, or this cycle will happen. And I'm going to let Hall kind of go through and talk about some of those connection points.
Yeah, so when you have this excessive voltage drop, there are a few things that can be causing the problem. So first thing you want to check is you want to check the fuses on the truck. So our system, like Jimmy said, is a 20 amp DC-DC converter. It can pull, max is probably 27 amps realistically, but generally 20 to 25 amps. So we want to make sure that that is on a 30 amp circuit. So first thing you want to check is go to your truck, make sure that the aux fuse is not blown, and if it's not, make sure it is a 30 amp fuse, so that it has it can handle the power that we're pulling through that circuit. If that is 30 amps and it's not blown, then you can move to the connection between the 7-way and the truck. So here you just want to make sure that the connections between the 7-way and the truck there are good, that there's no wires broken, that there's no corrosion. And this also includes, and I'll touch on this a little more in a later slide, but this also includes that receptacle between the 7-way cable and the truck. The 7-way cable gets unplugged from the trailer every day, but it rarely do we see it get unplugged on the tractor. So we have had times where we've tried to get that thing unplugged and we can't, you can't physically pull it off because there's so much corrosion and buildup in there. And that is going to severely or cause severe resistance within that circuit. So if the fuse is good in the truck, next thing you want to check is that 7-way connection between the truck and the wiring on the truck to make sure that that receptacle is good, make sure there's not corrosion there, make sure the wiring is good, and there are no cuts or any issues along that wire. Third, you can go to the trailer side, and you want to inspect the 7-way on the trailer. So again, our system is a 20 amp DC-DC converter. We need we need a 30 amp circuit in there. So you want to check the circuit breakers on in your 7-way nose box. Make sure that they are 30 amp circuit breakers. Now we actually recommend that our system within that nose box gets connected to the hot side of that circuit breaker. We have fusing, as we talked about earlier, we have 2 fuses in our direct controller. We've got a fuse and a circuit breaker back in the battery box. We have significant safeties along our system. Is there any issues? So allowing it to get all the power that it can coming through that 7-way is recommended. So yeah, so we recommend putting it on the hot side of the circuit breaker. If for some reason you can't do that, if the fleet you work for doesn't allow it, whatever it might be, just make sure that that is a 30 amp circuit breaker on the 7-way, so that again it can handle the current that we're pulling. If your 7-way is equipped with bullet connectors or whatever those connections are in there, just make sure that they are that they have a good D-style crimp, that they are connected solidly within that 7-way. Again, just to minimize the resistance coming through, and make sure that we're getting the power that is needed from the 7-way, and we're not having any voltage drop issues. And lastly, the 7-way cable itself is probably where we see the most issues whenever we have voltage drop come up. So you want to make sure that your 7-way cable is in good shape, that it is your ABS rated cord. A lot of times just wear and tear on these things, if they accidentally get dragged behind a truck or just being used in all kind of elements with all the debris on the road and everything, just making sure that 7-way cable is good is key to that system. So so you want to check the fuses in the truck. You want to check the connection between the 7-way wiring from the truck and the truck receptacle. You want to check the 7-way on the trailer, and you want to check the 7-way cable going between those two. And lastly, and probably most importantly, is you want to check these under load. So typically, whenever we're going out to check a 7-way, first thing a lot of people do is you'll take a multimeter and you'll take the positive and take the negative, stick it in the 7-way cable, and turn the truck on and say, okay, my voltage is good. It's 14.3 volts or whatever it might be. And then they plug it into the trailer, and lo and behold, we have the cycle that Jimmy just talked about come on, where it goes green and then it flashes back and forth orange, and then it goes green again, and so on. And the reason this happens is because you don't see voltage drop until there is a load on that circuit. So it's extremely important whenever you're testing this to make sure you test it under load. So this picture here is just an example. This is our double check, and basically what it is a false load. So it's a 20 amp load that you can plug the 7-way into and then pull a 20 amp load through that circuit. So you can plug a multimeter in and see what that voltage is when that load is being pulled. So you can use this, you can use a similar tool, whatever might suit you best, but it is key to make sure that you are testing that 7-way circuit under load. Sorry, in order to accurately measure if that 7-way is getting the power that is needed through it. And again, like Jimmy said, we don't see this much on the dual pole side, but the same principle applies. If you're testing this, if you do have issues on the dual pole side, if you're seeing this, make sure that when you test it, you're testing it under load, so you get accurate measurements. So with that, real quick, before we get to questions, we just want to go through and see, kind of hear a little bit from you about what you've been experiencing in your fleet. So this is one where you can check more than one box. We just want to hear what issues you see when diagnosing the units on your fleet. We've got some different options in there: the blown 30 amp fuse, the 2 amp fuse, the voltage drop issues, and the 4-pin harness that we've talked about here. We also have an option for other if there's something else that has come up, and if that's the case, we can try to reach out to you directly to hear a little more. And if you haven't seen any issues, then that is just as important for us to know, just to kind of see what the main things that are coming up. So if you could take a few seconds, kind of fill those in. Again, you can choose as many as apply. Just help us get a better understanding of what everyone's seeing out there. Alrighty. Thank you, everybody. And one more thing before we take questions, we do have some resources for you. We do have some resources for you. I'm not sure where that feedback is coming from. Anyone else can hear that? But so we do have resources. We have a checklist, which is essentially whenever you receive a new trailer, we have a checklist on our website that goes through what things you should look at. So what exactly you should be checking for to make sure the installation was done correctly, to make sure that the unit you're receiving is in good shape and should be received. We also have diagnostic guides and installation guides on our website. And like Jimmy mentioned earlier, those take you through step-by-step on these processes. They'll diagnose any issues that might come up. So those are all out there. We also, to help you along in your diagnostic work, we have a couple products that we have promotions on from this webinar. So we have our multimeter toolkit, which has a multimeter and a clip-on amp meter and a heat gun for $189.99. And we also have our double check that we talked about that can help measure those the voltage drop on those circuits under load. We have the full kit on sale for $585, and we also have smaller kits. So if you're just running a 7-way or if you're just running a dual pole, it comes with those specific attachments only, and those are each $490. So save a little bit of money on those. This $585 is for the full kit that gives you all the connections and everything. So if that's something that's helpful, we have a promo code for that. Webinar JF, and it expires at the end of November. So, and we'll get into the Q&A now. We've got 15 minutes or so to get those questions answered. But thank you all again for being here.
Thank you, Hall. And I was going through some of we do have some questions that did come in, and as we wait to receive more of those. It seems like the most common question would be that 4-pin plug that's plugged into the DC-DC converter. It seems like many have something along those lines, but really that is the last point of contact in that whole circuit. It's going to see the highest the amount of resistance and heat buildup. So we have taken into consideration and noticed that. We've changed some of our crimping styles here on the line. Just learning from what we've seen out in the field. So that, since we have done that, we have not seen that come back. So feel free to reach out to us, after this or at any time. We can get you set up with a new harness, 4-pin harness. But since then, that has been resolved. So if you have any more questions on that, feel free. We do have some processes that you can do to, when you replace that, you want to make sure that pin on the inside is cleaned off before you plug the new 4-pin harness back in. Because again, that's going to, that if it's not cleaned off, it's just going to create resistance, which in turn, with the, maxing out the charger at 25 amps, that resistance is going to turn into heat. So you want to make sure, when you do replace that 4-pin plug, take like a nail file and clean the soot off that pin. Then you shouldn't have any issues. So I think that's, looking at all the questions, that's going to answer a lot of them. And you got another question. If it's a 20 amp charger, why do you recommend a 30 amp fuse? Again, it is a 20 amp charger, but it does max out at about that 25 to 27 amp range. So just to prevent a nuisance, we recommend that 30 amp fuse. The whole circuit should be protected with a 30 amp fuse. If you step down to a 20 amp fuse, you're just going to be dealing with nuisance blows. Even on the circuit breaker, it's just going to sit there and trip and just cause you all kinds of problems. So that's why we recommend the 30 amp fuse.
We do have one question here regarding there are some systems that can come with a switch in them that have number 1, number 2. So just to clarify that for anyone out there who's using these switches, and Jimmy, you can touch on this too, but if it's on number 1, that will be our system. If it is on number 2, that is the bypass. So in order to use our system, we want to be on switch number 1.
That is correct.
Yep.
Next question here is, does the direct charging system affect my ABS system? It does not. That's one of the key features of this system is we shut off, some of our earlier models, we actually use a signal from the brake to shut down our system and allow the ABS the full voltage it needs. But we kind of realized over the years that, these big city routes, if we're shutting off when the brakes are applied, what happens the majority of the time when you're in the city? Those brakes are applied. So you're losing out on a lot of charging opportunities for those liftgate batteries. So knowing that the voltage that the ABS needs to operate, we just shut off right before that happens. So we save all the power the ABS needs to operate. So that's one of the key features of our direct product. I've gotten a couple questions on the lights. What is the purple mauve light on the direct controller? I'm not sure if I've ever seen that, but really there's only 3 LEDs as far as colors. We have a green, an orange, which is the reason why we pick orange is because law enforcement, we can't have anything forward-facing red or blue. Well, we do have blue, but forward-facing red. So we have green, orange, and blue as our colors. If it's anything other than that, then I would recommend, calling our tech support, and I would assume it would have to be something wrong with the controller. But you should not get a purple or mauve light. What is the part number for, another question that came in, what is the part number for the 4-pin harness? That would be part number H as in hat -00276. That's H-00276. So feel free to call our customer service or technical department. They'll get you set up with that harness. Make sure I understand this question. I think they're asking, have you had a failed main switch on the battery box, which you can switch it to straight from the truck or the DC-DC converter? Just with my experience, I can't recall ever seeing an issue with that. It's a red switch. It's basically it's a 1-2 switch. It's 1 off and then switch it over to 2. That's a pretty solid switch. I haven't seen any issues with that. But I would be interested, if you want to call in, I'd be interested to see what kind of issues you're having with it. And we'll reach out to you as well after the webinar. We got another question that came in on possible some water intrusion into the direct box. Is there a fix for that? We'll reach out to you on that. I will say that all the electronics in the direct controller, and I'll hold it up here. They're all the electronics are potted, so the electronic portion of it is sealed. The part to worry about would be your possible corrosion on your studs. But all the electronics are pretty sealed. We do also put, this would be really tough to see, but we do put a hole at the bottom of that controller for any water that, standing water that does get inside that controller. We allow it to escape out. So if water does get in, it will be able to escape from the inside and not, build up inside. We'll give it a couple minutes to get some questions in. Again, don't go away after this. We will have a short survey afterwards. So everybody, please stick around for that. We will have our next webinar. Will be very similar to this one, but it's going to go over the select liftgate charging system. Basically all the same logic, but you'll get multiple sources to pull power from. Okay. Thanks, everybody, for joining us today. It was a pleasure. I know Paul and I were excited to present this one. Again, we'll follow up with everybody that has sent questions in. And again, please stick around for the survey and join us next time on troubleshooting the select liftgate charging system.